So on this one, we're not given R of t. So that would actually be our first step, is to find R of t, which means instead of having 8 steps to the problem, we now have 9 steps, because we have to find R of t first. For a vectored value function, if you want to create a circle, all you need to do is put cosine in the x component, and then put sine in the y component. If you leave the coefficients as 1, that would create a circle with a radius of 1. In this case, we want to make a circle with a radius of 4, so all you have to do is put a 4 in front of the cosine and a 4 in front of the sine. If you haven't yet gotten beyond this point, then please pause the video and try working out the rest of this on your own. Okay, so now we've found R of t, so that first step is done. Next, we find R prime of t. The derivative of 4 cosine t would be negative 4 sine of t. Derivative of 4 sine t would be 4 cosine of t. Next, we need to find the magnitude of R prime of t. That would be the square root of negative 4 sine of t squared plus 4 cosine of t squared. That would give us the square root of 16 sine squared of t plus 16 cosine squared of t. We can factor out a 16, and actually, since 16 is a perfect square, let's just go ahead and pull that out of the square root as a 4. And then we're left with the square root of sine squared t plus cosine squared t, which we know is 1. The square root of 1 is 1. That means we just have a 4. Next, we need to find s of t, which is going to be the integral from a to t of the magnitude of r prime of t dt. We weren't given boundaries for this, but we know that a circle goes from 0 to 2 pi, so we're going to set a equal to 0 for this problem. S of t is the integral from 0 to t of 4 dt. That would be 4t from 0 to t, which is 4t. Take your s and set that equal to 4t, and then solve for t. That means that t would equal to s over 4. Now we can find r of s by plugging s into the r function. So our r of t formula was 4 cosine t comma 4 sine t. So now that would be 4 cosine of s over 4 comma 4 sine of s over 4. Next, we find r prime of s. We're going to have to use chain rule. So the derivative of cosine is negative sine s over 4. And then we have to multiply that with the derivative of what's inside, which is 1/4. Same thing with the second one. So we'd have 4, derivative of sine is cosine, and then derivative of what's inside is 1/4. The 4 and the 1/4 are going to cancel for each. That gives us negative sine of s over 4, comma, cosine of s over 4. Now we can find t of s, which is r prime of s divided by the magnitude of r prime of s. R prime of s was negative cosine of s over 4, comma, sine of s over 4. And the magnitude of that would be the square root of both of those components squared. That denominator is equal to 1, so we get negative cosine of s over 4, comma, sine of s over 4. Right now you might be asking yourself, is that denominator always going to be equal to 1? And the answer is yes. As far as I know, that denominator is always going to be equal to 1. There could be a situation where it's not equal to 1, but I haven't seen a problem like that yet. So we're done finding t of s. Next, we need to find t prime of s. So the derivative of negative cosine of 4 is going to be a positive sine of s over 4 times 1/4. And then the derivative of sine of s over 4 is cosine of s over 4 times 1/4. So that's the t prime of s done. And finally, we can find k, which is the magnitude of t prime of s. Magnitude of t prime of s. So that's going to be the square root of 1/4 sine of s over 4 squared plus 1/4 cosine of s over 4 squared. That gives us 1 over 16 sine squared of s over 4 plus 1 over 16 cosine squared of s over 4. Let's factor out the 1/16, and we can actually pull that outside of the radical as a 1/4. And then we're just left with the square root of sine squared plus cosine squared, which is square root of 1. Square root of 1 is 1. So our curvature, finally, is just equal to 1/4. You might notice something here. We started off with a circle with a radius of 4. We ended up with the curvature of 1 over 4. That is not just a coincidence. In general, if you have a circle with any radius r, your curvature is going to be 1 divided by the radius. So if we have a circle with a radius of 5, then the curvature for that circle would be 1 over 5.